Hi, this is Samir, and I'd like to show you a pretty cool feature of the new version of DPIT Effex 1.7, which now includes a point rendering solution by using the Cineman, the Cinema 4D Cineman connection to a Renderman compliant renderer. And well, let's just get started. So the first thing we should do in order to get our point renderer is to download a Renderman compliant renderer, right? So I'm using 3D Light, which is a pretty cool renderer, and the very great thing about it is that an individual license is free of charge. So we go to 3D Light here, 3dlight.com first to get to the web page, and then here to the 3D Light page and go to download. And well, here we have it again, a maximum of 1 free license available per customer. It is not restricted for commercial use or anything. It's not time limited. The only restriction is that it will only use 2 cores during rendering. So, but otherwise it is free. So download the according version for your operating system. And I have Windows 64-bit, so I will click here and download it. And then just follow the instructions of the installer to simply install it, which I have already done, of course, so I won't show you this now. I think you know how to install an application. And once that is done, we go into the according folder of 3D Light where it has been installed, and that is here, and we go into the shaders section, because when you download version 1.7 you will find a Renderman shader in the DPIT folder, and you simply copy it here into this 3D Light shaders folder, and the name of it is Real Smart Motion Blur. And this is a shader that allows later on to create motion vector, a motion vector pass or channel to be used in After Effects with Real Smart Motion Blur. So a direct solution for this is also available for the point rendering. But that's actually all we need to do. Well, if you haven't set it up, of course you need to go now into the Cinema 4D preferences with Control E, into the renderer section and into Cineman. Of course you need to have Cineman, right? So without Cineman you unfortunately cannot use this feature. I'm not sure if it is only in the studio bundle of Cinema 4D, but please check out the Maxon website to find out. Well, and we have some settings here, and 3D Light is set as the renderer. We could also use Arrow or PRMan, but I have 3D Light just installed, and the application directory would simply go like this and then choose the according directory that we were just in to define it. Temp rip storage, keep it at local please, because I noticed that when you set it to project directory there's kind of a bug. I'm not sure if Maxon is aware of that, but whenever I have set this to project directory, the renderer just kept idling and didn't render even with just a cube in it. So I keep it in local, it's absolutely no problem. Well, and that's actually it. We can now start point rendering. There are just 1 or 2 more clicks to accomplish this, but the first thing we need is the new RIBery object. Yeah, maybe the Europeans might know Frank RIBery. It's a soccer player in Germany. He plays in Germany currently, but he's French, and he's a really fast and smart and clever guy, and playing hell of a soccer. But beside that, we of course first need our scene, but we need the RIBery object, which is the actual connection, or which allows us to point render our particles. That's what this is all about. We can now render millions of particles with minimum memory consumption using the RIBery object of DPIT Effex. But okay, let's just see what we have here. We have a scene, a simple one, 2 emitters emitting liquid, one down here, the other to the other side. We have 3 obstacles, just 2 cylinders and something where the water can flow through to make it more interesting. Yeah, also have some foam here, but we won't use it here for this presentation of the RIBery object and point rendering. But let's just play a simulation, and you can see it just spits out water. And what I could do now, of course, is I could use the mesher like this and generate a mesh for the particles. I'm gonna render this now just to see what this is about. So that is the scene that we have here, and but I would like to render the liquid particle points. I don't want a mesh. I want something more stylized. Okay, so turn the mesher off again, and I completely turned off so it's not generated during rendering. So we have our points, but of course if we don't have a mesher and I render this, we don't see anything because Cineman 4D doesn't have a point renderer. So we go into our render settings, and the first thing we see is the render engine that we could use here, and of course we use Cineman, right? Because we want to use the 3D light renderer to render our particles as points. So I choose Cineman, and I now go into the Cineman tab here, and right into the translation tab where we have the paths, and we come back to this in a few seconds. So we just keep this in mind. Close it, and now we create our RIBery object. Right. So there we go. Okay. So we see the settings now here in the attributes manager, and what we first need is the particle object that we want to use, which is our liquid solver, because it has the liquid particles in it, like this. And the second thing we need is we need a path to the archive folder. In Renderman compliant renderers, there's a certain file format which is called RIB, and it can be used as kind of archives. So something you grab, you put somewhere, and you just grab it when you need it. And that's actually what these archives are. So we need to select or choose a folder where we would like to create these archives. Well, RIBery will create it. But if you don't care, you don't have to care actually. If you just want to render your points here, and then just click on it, and here I go into my computer, and I've just already created one here, the RIB test folder, and I choose it. And alright, so and now we gotta get back to the render settings, and we also have to define this path, this archive folder path, here in the archive path of the translation tab in the Cineman tab. So click here and just do the same, just define it like this, RIB test, and there you go. That's all you need to do, right? Install it, define it in the Cineman 4D preferences, the 3D light renderer, create a RIBery object, define the path to the archive folder in the RIBery object and in the Cineman settings and the render settings. And that's it. And now we can start our point rendering actually, right? So I close this now, and well, we have the particle type to be rendered set to foam. Of course, we don't have foam yet here, so we need to choose liquid, like this. Alright, so yes, actually that was it. So if I now render, it will now use the 3D light, and as you can see, we can now render our particles as points. And this is really great because it really does not use any RAM at all. It's like magic, I don't know. Well, it really uses only a little RAM to render a huge amount of particles as points. Right, so that's actually all we need, and we can now define here different colorings. For example, we can define the color by, for example, the acceleration that we also see here in the editor actually. And let's just put this to 5, which is the maximum value for the acceleration. So if the acceleration reaches 5 meters, then it will be white, and if there is no acceleration or no velocity at all, it will be black because it will be 0. So you can define the color here with the gradient, but let's just put something visually more pleasing just to see how this looks like really. Like so it's really the same thing, and if I put this to 15, well, it doesn't look much more different because it's so fast probably. So let's just put this to 35. Now this is getting boring, so I put this higher a little bit. I kind of get the feeling that this is not the appropriate frame for showing off. Well, okay, let's just move a little forward. I would like to show you this now. Yeah. Okay, let's just choose this one for a last try. Yeah, well, you can see the red areas are slower moving particles, and the yellow ones are pretty fast, approximately faster than 35 meters. Well, but okay, so you get the point. There's other stuff we can use, for example, the vorticity or the age of the particles. I have age because I'm using the variable property type here and have the age activated. So if there is a property in use, we could choose it here for coloring. We can also define different radii. When I put this higher, set this to 9. Oh, of course I have to turn off only during rendering. So you can see renders points. Very great to render a lot of foam, for example, or for stylized motion graphics or similar things. So very, very cool and very easy to set up, and just the setup is very fast, and then it's all about tweaking the settings to get to something you like. You can base the radius also on all the different attributes. We can define different transparencies, and the cool thing, we can also render this either as particles, as we have it here, which means if you don't care about shading of the particles, for example, when you're rendering foam, there's not much, especially when you have open water scene or something where actually the points are the only thing seen and not much shading or any shading at all, just white points, then choose the particle. It's fast, it's lightweight in memory consumption, but it doesn't include any shading, so perfect for foam actually. We could also use spheres here, which will have a shading actually. So also here we can render a lot of points as spheres. And we also could use a disk, which is really a three-dimensional disk that is always pointing at the camera. And it can also use shaders, if I remember correctly. So you can put shaders on it and it will use these. But of course, if the disk is not appropriately aligned to the light, then the shading doesn't matter actually. So and we can also render it as an implicit blob, so metaballs actually, and I just crank this up to 25 because that's the energy radius of the metaball to create the isosurface. So also this can allow us now to render like metaballs pretty fast. But actually the point rendering is the whole point of this thing, to render really a lot of objects or a lot of particles, especially the liquid particles where we have the foam, as I mentioned already, or simply to create nice looking dust, or anything creative you can imagine. We see particle renderings everywhere in advertising or in the movies. You can also render smoke, for example, and composite it all into your normal Cinema 4D rendering in After Effects. And now that we're talking about After Effects, I would like to show you the last feature here. Is pretty cool, and that we were talking about in the very beginning, which are the motion vectors for these particles. So especially when you have really tiny particles and so and foam, etc., you would like to add motion blur to it, and the best way is to have a motion vector pass for these particles. So all we need to do to make this happen actually is to activate the generate motion vectors channel, right? And then you have the motion scale here, which is given in pixel, and in Real Smart Motion Blur in After Effects, this would be the value max displace or maximum displace. I don't remember really. I think it's max displace. So set this to the same as in After Effects or vice versa. So set the same in After Effects as you set here to get a good motion scale. And the motion vector image should be saved to the Archive subfolder. We could also use the multipass folder that we have defined in our render settings. Here, when I activate multipass here like this, it would then take this path right away. But I keep it at the Archive subfolder, so I have one folder where I find all the stuff that I have from Renderman or from the point renderer. I could also generate into a Cinema 4D multipass. But for everything, we need two things. First of all, we need a camera, right? We definitely need a camera to generate our motion vector data. Okay, and at least if we want to save it to file, right? Because I could also now use, once I activate generate motion vector channel, I could also color it according to the motion vector. Like when I do this now, there you go. So it's just rendered as with the motion vector, as a motion vector pass actually. So but we would like to create it into a known file. Yeah, but that's all you need to do. Just activate it, and actually that's it. Generate a camera, that's what I said already. And the last thing is we create the RIBery video post, right? That is necessary. I almost forgot. Yes, it is necessary. So generate a RIBery video post and camera if you want the motion vector pass to be saved to your hard disk, right? Okay, I lowered this to 50. Come on, let's keep it at 75, fast enough. And well, I could now render my points, right? I just go back into my RIBery and I lower here the radius again, and well, don't forget the shader must have been copied from the DPIT folder into the 3D Light Shaders folder. But I now go into that object folder that I defined here, and the motion vectors will be saved into this subfolder, object subfolder, as we have set it. And I delete all these previous render tests. And okay, so let's turn the saving off so I don't have to overwrite old files. Okay, so, and here we go. Here's our first frame already, and the second, and all the others will follow. So it will then generate the motion vector pass into this folder. Yeah, I just keep on talking because I don't know if I'm talking too few or too little, because it's so fast to set up. Yeah, that's actually all you need. You could now then use these motion vector passes in After Effects to add motion blur by using Real Smart Motion Blur. And very, very great thing to have. A full point rendering solution now in Cineman 4D via DPIT Effex 1.7. Have fun with it.